The National Electrical Code does indeed address the use of neutral conductors in high intensity discharge, abbreviated HID, lighting circuits. Specifically, the NEC mandates that in certain installations, each HID lighting circuit must have a separate neutral conductor. This requirement is not arbitrary, it stems from the operational characteristics of HID lighting systems and is intended to mitigate potential electrical hazards. To understand the rationale behind this rule, it's crucial to consider the nature of the current waveform in HID lighting circuits. HID lamps, such as metal halide, high-pressure sodium, and mercury vapor lamps, often employ ballasts to regulate the current flow through the lamp. These ballasts can introduce harmonic currents into the circuit, particularly third harmonic currents. Harmonic currents are multiples of the fundamental frequency of the AC power system, which is typically 60 Hz in the United States. The third harmonic, therefore, has a frequency of 180 Hz. Now, here is where the problem arises. In a three-phase, four-wire system, the neutral conductor carries the imbalanced current from the three phases. Under normal conditions, with balanced loads, the neutral current is relatively small. However, when significant third harmonic currents are present, they add arithmetically in the neutral conductor, rather than cancelling out as the fundamental frequency currents do. This can lead to a neutral current that is substantially higher than the phase currents. If the neutral conductor is not adequately sized to handle this increased current, it can overheat, potentially causing insulation damage, a fire hazard, or even a complete failure of the neutral conductor. The NEC addresses this issue by requiring a separate neutral conductor for each HID lighting circuit in certain applications. This ensures that the neutral conductor is sized appropriately to handle the anticipated harmonic currents without overloading. It's important to note that this requirement is not universally applicable to all HID light installations. The specific conditions under which separate neutrals are required are detailed in the relevant NEC sections. Let's delve into the specific NEC sections that govern this requirement. While the exact section number can vary depending on the edition of the NEC, the general principle remains consistent. Typically, the NEC section addressing neutral conductors and harmonic currents will contain provisions related to HID lighting. One key section to examine is usually found within Article 220, which deals with branch circuit, feeder, and service calculations. Within this article, there will be subsections that address the sizing of neutral conductors, taking into account the presence of nonlinear loads such as HID lighting. The NEC specifies that for circuits supplying electric discharge lighting, which includes HID lighting, the neutral conductor must be sized to carry the maximum unbalanced load. Furthermore, if the major portion of the load consists of nonlinear loads, the neutral conductor must be considered a current-carrying conductor. This means that its ampacity must be derated accordingly based on the number of current-carrying conductors in the raceway or cable. Another relevant section is often found in Article 310, which covers conductors for general wiring. This article provides ampacity tables for conductors, as well as correction factors for ambient temperature and the number of conductors in a raceway or cable. When sizing neutral conductors for HID lighting circuits, it's essential to consult these tables and apply the appropriate correction factors to ensure that the conductor's ampacity is sufficient to handle the anticipated current. Now let's consider some practical examples to illustrate how this requirement applies in real-world scenarios. Imagine a large warehouse that is illuminated by numerous metal halide lamps. These lamps are powered by three-phase, four-wire circuits. If the lighting load is substantial and the ballast used in the metal halide lamps generates significant third harmonic currents, the NEC would likely require that each HID lighting circuit have a separate neutral conductor. This would ensure that the neutral conductors are adequately sized to handle the harmonic currents without overloading. Alternatively, consider a smaller office building that uses a limited number of compact fluorescent lamps, abbreviated CFL. CFLs, like HID lamps, can also generate harmonic currents. However, if the overall lighting load is relatively small and the harmonic content is not excessive, the NEC might not require separate neutral conductors for each CFL circuit. In this case, a shared neutral conductor might be permissible, provided that it is adequately sized to handle the anticipated neutral current. It's crucial to emphasize that the decision of whether or not to use separate neutral conductors for HID lighting circuits should be based on a thorough engineering analysis. This analysis should take into account the specific characteristics of the lighting system, including the type of lamps, the type of ballast, the magnitude of the harmonic currents, and the overall loading of the circuits. A qualified electrical engineer should perform this analysis to ensure compliance with the NEC and to minimize the risk of electrical hazards. In addition to the NEC requirements, it's also important to consider any local codes or regulations that may apply. Some jurisdictions may have stricter requirements than the NEC, or they may have specific interpretations of the NEC that must be followed. It's always best to consult with the local electrical inspector to ensure that the installation is in compliance with all applicable codes and regulations. Furthermore, it's essential to use high-quality electrical components when installing HID lighting systems. This includes conductors, connectors, and overcurrent protection devices. Using substandard components can increase the risk of electrical failures and hazards. Conductors should be properly sized and installed in accordance with the NEC. Connectors should be properly tightened to ensure secure electrical connection. Overcurrent protection devices, such as circuit breakers and fuses, should be selected and installed to protect the circuits from overloads and short circuits. Proper grounding is also crucial for the safe operation of HID lighting systems. The grounding system provides a low impedance path for fault currents to return to the source, which helps to trip overcurrent protection devices and prevent electrical shock hazards. The NEC specifies detailed requirements for grounding electrical systems, including the size and type of grounding conductors, the methods of grounding equipment, and the bonding of non-current carrying metal parts. In summary, the NEC does indeed require separate neutral conductors for HID lighting circuits in certain applications. This requirement is intended to mitigate the risk of overheating and failure of the neutral conductor due to harmonic currents. The specific conditions under which separate neutrals are required are detailed in the relevant NEC sections. It's essential to consult these sections and to perform a thorough engineering analysis to ensure compliance with the NEC and to minimize the risk of electrical hazards. Additionally, it's important to use high-quality electrical components to properly ground the system and to consult with the local electrical inspector to ensure compliance with all applicable codes and regulations. The requirement for separate neutrals is closely tied to the concept of neutral conductor sizing, which is a critical aspect of electrical system design. The NEC provides detailed guidelines for sizing neutral conductors, taking into account various factors such as the type of load, the presence of nonlinear loads, and the number of current-carrying conductors in a raceway or cable. When sizing neutral conductors for HID lighting circuits, it's essential to consider the harmonic content of the current waveform. As previously mentioned, HID lamps often generate significant third harmonic currents, which can add arithmetically in the neutral conductor. To account for these harmonic currents, the NEC may require that the neutral conductor be sized at 200% of the phase conductors in some cases. This means that the neutral conductor must have twice the ampacity of the phase conductors. The decision of whether or not to increase the size of the neutral conductor should be based on a thorough analysis of the harmonic content of the current waveform. This analysis can be performed using a harmonic analyzer, which is a specialized instrument that measures the amplitude and frequency of the various harmonic components in the current waveform. If the analysis reveals that the third harmonic current is significant, then the neutral conductor should be sized accordingly. In addition to the NEC requirements, it's also important to consider the recommendations of the ballast manufacturer. Ballast manufacturers often provide specific guidelines for wiring and grounding their ballasts, including recommendations for the size of the neutral conductor. These recommendations should be followed carefully to ensure the safe and reliable operation of the HID lighting system. Furthermore, it's essential to ensure that the neutral conductor is properly identified. The NEC requires that the neutral conductor be identified by a continuous white or grey marking. This marking helps to distinguish the neutral conductor from the phase conductors and the equipment grounding conductor. Proper identification of the neutral conductor is crucial for preventing wiring errors and ensuring the safe operation of the electrical system. In addition to the specific requirements for HID lighting circuits, the NEC also contains general requirements for neutral conductors that apply to all electrical systems. These requirements cover topics such as the minimum size of neutral conductors, the methods of connecting neutral conductors, and the grounding of neutral conductors. It's essential to be familiar with these general requirements when designing and installing electrical systems. One important general requirement is that the neutral conductor must be grounded. The NEC requires that the neutral conductor be connected to the earth at the service entrance. This connection provides a low impedance path for fault currents to return to the source, which helps to trip over current protection devices and prevent electrical shock hazards. The grounding of the neutral conductor is a fundamental safety requirement that must be followed in all electrical systems. Another important general requirement is that the neutral conductor must be insulated. The NEC requires that the neutral conductor be insulated with a suitable insulating material that is rated for the voltage and temperature of the circuit. The insulation helps to prevent short circuits and ground faults. The insulation should be inspected regularly for signs of damage or deterioration. In conclusion, the NEC requirements for separate neutral conductors and HID lighting circuits are a critical aspect of electrical safety. These requirements are intended to mitigate the risk of overheating and failure of the neutral conductor due to harmonic currents. By following the NEC guidelines and recommendations, electrical professionals can ensure the safe and reliable operation of HID lighting systems. This involves a thorough understanding of harmonic currents, neutral conductor sizing, grounding, and other related topics. It also requires careful attention to detail and a commitment to quality workmanship. By adhering to these principles, electrical professionals can help to protect people and property from electrical hazards. Understanding the code and applying it effectively leads to safer electrical installations for everyone. The purpose of the code is to provide a minimum standard to adhere to for safety.